So far this year, we've talked about the atom in many different ways. We started with just our dot. We moved into how they're spaced out, so they can be clumped together as solids, they can be spaced out really far apart as a gas, or they can be a liquid. Then we found out these different states also have energy associated to them, leading us all the way to the plum pudding model when we looked at the cathode ray from J.J. Thomson. So we have these electrons we know that are floating around in this positive body. So over time, scientists like to test things, and this was tested by Rutherford. So Rutherford decided to run the gold foil experiment. So he took this box which shoots, it was a lead box with a tiny little hole in it, that it had some radium in it, and it would shoot these positive radium particles through gold foil and then record kind of what happened. Now, if Thomson was correct, and if this model was the right one, these particles would just travel straight through to the other side. This is what should be seen. However, that's not what actually happened. What actually happened was that he shot these positive particles, some bounced back, most of them went through, and some kind of deflected off to the side a little bit. Now this is a fluorescent screen, so it was able to capture where things were hitting it, and the biggest grouping was straight through. There was just little bits of evidence that it went out to the outside. So these are the things he noticed. Some things bounced back, some repelled slightly, but most things go through. This led him to be able to make certain assumptions because he knew that this particle that was being shot at it was positive. So there's a small, dense, positive nucleus. That was his first big assumption, is that there's this tiny little dot inside of the atom, and it's positive. And then the other part is that the atom is mostly empty space. So in earlier classes, we did the thought experiment of a marble at the 50-yard line of Gillette Stadium, and the entire stadium is the rest of the atom, and that marble is that little itty-bitty nucleus. This is what Rutherford's final model ended up being. It had a positive nucleus, and most of this thing is empty space, and we have some electrons floating around the nucleus. Now, Niels Bohr, he comes around and he decides that that model is okay, but it can be improved slightly because of physics. So if they were just floating in this area like this, everything would be compressed toward the nucleus. The positive and negative would attract. There has to be energy associated to this. So he then took this orbiting kind of model here, this planetary model of an atom, where these electrons are going to be moving in these energy levels, and they could be moved in between them. And there's the positive nucleus right in the center. And this also helped us explain spectra. So when we were having a gas tube and we put energy through it, so I had an electrode here, and it shot through that screen, we saw light. And what was going on was really quite amazing. And they realized that this was also like a fingerprint. Every time they did it to hydrogen, they would get these spectral lines. So if you remember, we put on glasses and we saw these spectral lines show up when we had this emission of this gas going on. So what he proposed is that an electron, it's going to start in its ground state. When we give it energy, it's going to move up to another energy level. And that energy level is going to have more overall energy in it. And then eventually, because it's going to want to go down to its nice stable ground state, it's going to release that energy. And when it releases that energy to go back down to the ground state, it's going to release light. And the color of light is going to be dependent on how much energy is released, or how far back to ground state that electron has to travel. So we go from this ground state to this excited state where it moves further away, and then back down to the ground state. And it's this moving back down. That's where we get that light spectra. And currently, that's going to be our new model. So this is now the model that we'll be using for pretty much the remainder of the year, where we're going to look at how the electrons move and also what properties this atom can now have. All right, we'll talk to you soon.